Welcome to class. So today we're going to talk about visual servoing. The idea behind visual servoing is that we're going to actually try to track an object with the camera while it's moving. So visual servoing is useful in a lot of contexts. For instance, you can use this to follow a leader. You can use this to actually maintain a distance from another robot. And it's really one of the core elements where we're seeing the combination of using vision techniques to detect an object in the environment and being able to react to this. So this allows us to do closed loop control. In class today, what I'm going to show you is basically how to get our Balboa robots to actually track a ball like this using our camera. So to start out with, I'm going to show you some of this code that I wrote to actually do blob detection with these balls. Okay, so what I have here is code that is actually aiming to detect these types of balls. So if we look in this image, we have both the original image here, where we're showing basically the ball where it's being tracked. And this is basically a representation in HSV, but displaying in the RGB color space. So it's a little weird image, but it's useful. And then this one here is showing a threshold image where we're able to where we're only setting it up to detect, basically colors in this range. So here we have the H value, the low threshold on this side, where you can see if I set it much lower, it gets much more of the image. If I set it higher, it filters out a lot of that. And what we can see is that, we can have basically a somewhat narrow range in the H value and a pretty wide range in the saturation and the value. So from here we have a wide range. And what this lets me do is if I turn off my light, you can see that the overall color of the ball is actually going to change, but the HSV values don't change very much. So this is what lets us, why we're wanting to use the HSV color space. So with this, we can identify and track it through here. So this is basically doing blob detection, and then it's fitting a circle to the points there so that we're able to track it. And we're also able to track the center point here and the radius. So if I take my camera and actually now mount it to a robot, I can use this to actually implement tracking. So let me get this set up on the robot and I'll be right back. Okay, so I have my camera now balancing on my robot here. And now if I start some visual servoing code, it's going to use the same ball detecting code that I just showed you. So if we go here, and now what happens is when it sees the ball in the image, it'll basically track it back and forth by rotating to follow the ball, or going back, if I can get it in the image. And one of the challenges you'll note with visual servoing is it needs to be able to see it at all times. So the question is, what do you do when it goes off the screen? And so you may want to just stop, or you may want to actually keep tracking and trying to find it. So here you can see it actually following. And if we had class, we would have been doing some of this in the class, where we would actually implement visual servoing behaviors. But unfortunately, since we don't have our robots anymore, You're just going to have to watch this video and trust that it is fun to implement. So one of the things with visual servoing is that you can do this just using a bang bang controller where you're going just left and right based on what you see. You can also do this using a PID controller, or even more advanced types of controllers based on what you want to see. But the fun thing is that it's pretty straightforward given ROS to be able to actually connect the various nodes together so that you can process image data and output controls for your robot. So I hope you enjoyed a little bit of visual servoing. This is definitely a useful tool in robotics to be able to track objects with a camera while you're moving, and relatively straightforward to implement using ROS to do image processing and output the control messages based on that.